All right, we have for your viewing pleasure an A2918. The battery seems to have melted itself, and I think this is probably what caused damage to our board. There's no signs of liquid damage or anything like that. It's a little bit dusty, but really quite clean. This is actually mailed in to us from Hawaii, of all places. It was from a longtime customer of ours who used to live down here. They moved it out to Hawaii. No one near them can help them, so they sent it here, which is really cool. In this case too, they had actually, I think it was for this customer, one of their kids maybe, and they had already gotten a new device, so this is just sitting around. So they'd asked if we'd maybe buy it, which we do, so we'll kind of take what it's worth and minus the repair cost and then offer that to them, so this doesn't just end up in a landfill somewhere. We can resell it or use it for something. Let's have a look at these batteries a little bit closer. We can see these kind of melted over here. This must have gotten quite hot. See that same sort of thing there in the bottom of the BMS, like these plastic things melted. So battery's bad. We ordered a battery, we'll get that, but the board's also not working. So let's see what this does. I've been recording a lot of videos recently because I feel like I haven't had anything that was particularly interesting or new. This is an M3. I think there's very few videos on these. We actually have a schematic and a board view file for these now, which is nice. We didn't have that last time I made a video on one of these. We're going to measure our PP bus voltage. This probably has a problem on PP bus. I was actually, I thought I was recording for 5 minutes. I already kind of did everything I'm doing now, so I'm pretending like this is the first time looking at these. So what we see on this, 5 volts, very low current, and really that sort of, current draw, this 5 volts, like, 0.01 amps is really often going to be some kind of PP bus issue. We measure our voltage on the PP bus fuse, right? We're getting 91 millivolts both sides of the fuse. Here, actually zoom in on this. There, right? So we're getting 0.9 millivolts on there. I'm going to unplug power. Let's get a resistance measurement on the line. See if we have a PP bus short. We do. I'm tangling my multimeter probes here. And we're not getting like a hard short on this. I think we're getting like about 90-ish ohms. There we go, 94, 95. We can get exactly 95, something like that. Quite low. This should be, several thousand ohms to ground. So we would typically call this, like a partial short circuit, basically. This is still far too low for this line to function properly. But, we'll still kind of solve it the same way. We're going to solder a wire onto the line, inject voltage, and see what gets hot. And replace that, or just remove it. So I'm going to get this board apart. We'll have a further look. Perhaps there's something that's obviously bad and exploded. Certainly nothing on the top side jumps out at me immediately. So maybe there's something on the back that's obviously bad. If not, then we'll inject voltage into it and find what's causing our problem and see what it does. Okay, so there's water damage on the back. That is what did this in, I would bet. And this is probably what is pulling down our voltage on Le PP bus. So I think that's, I'm just going to desolder these. I'll desolder these caps, see if the short goes away, then we can look at that chip from the side. Otherwise, I don't see much that concerns me. A little bit, dusty otherwise, and that's really it. I noticed the keyboard was almost kind of like bulging in on the top case. There's some other schmutz over here. Nothing too concerning. Let's get this crap off there. Turn on the hot air, get some flux. Remove these fellers, and we'll see if our PP bus resistance climbs back up. Let's see what our resistance is on le PP bus now. Exactly the same. Let's remove that audio driver. Because I may have an internal board short circuit. Yeah, it doesn't really look that bad. I doubt we have an internal short. It's probably this chip. And I believe this driver is the same on like M1, M2, so I can just pull one of those, reball it, get it on here. I got shaky hands today. Okay. Yeah, and that doesn't do great. Okay, let me get some flux on there just to kind of straighten out these parts. Now let's see our PP bus resistance. Okay. Same thing. Okay, we're probably going to inject voltage into it and see what's going on. Those parts were quite clearly bad, so I'm actually going to see what this does on a USB-C meter now. Let the board pull down first, and then we'll run power in it again and see if anything changed on that front. We'll see. We'll see what is causing our problem. Might just be some other cap in this area that doesn't look obviously bad. But yeah, we're going to let this board cool down, and then we'll run power through it and see what it's doing. All right. I might be tweaking, but I can swear that this thing is thermal signaling ever so slightly. Let's look at the camera. Let's look. You guys can see it too, right? You guys can see it too. I can kind of see it comparatively, but it's pulsing a little bit. So I'm going to just be tweaking, but that shouldn't do that, at least in this state. So I'm going to remove it. See if our PP bus voltage goes up. Oh, I must take a call. We'll be right back. Yes or not? That was it. So we can just measure our PP bus speaker amp line here now. And you can see we're getting a much higher resistance value. It's climbing up. It's going to go up to a few thousand ohms. Board's really hot right now. I'm going to go grab a donor for like an M1, M2, pull these drivers, and reball them, get them back on there. And I think that's all we need. A few other things. I'll probably find... we'll just replace these capacitors too. I think what we basically had... I'll replace this this big guy right there. UR630. That was bad. I'm going to double check this part number. I'm 99% sure that this is the same thing on M1, M2, M3, 14, 16-inch, same chip. This is the same thing, which is fine. This is not an inherently bad part. Just had some liquid damage over here. And then I think... Oh, actually, this guy had a bunch of burned pads. Was it? Am I losing my mind? There's something over here, too. Oh, yeah, it's kind of... There we go. What we had, this guy. Maybe we'll go ahead and swap that guy out too. I think I can just find something similar on another board. I don't have an exact donor for this M3, but I have some M2, M1 boards that we should be able to use. So we'll find those parts, and we'll be right back. All right, through careful thinking of the exact same pinout, basically. Everything matches here, all the lines, names, etc. I'm just gonna swap them, and we'll see if the audio works. I think it's fine. Probably just different, like the chips actually have physically different markings on top of them. But I think that might just be like, you know, revision or batch numbers. Perhaps I'm wrong, we'll see. All the pins and stuff match out, so it's not like these are gonna like blow up if they're not exactly the same. There might just be weird shit with the audio, and in that case I'll source an identical part, basically. More here. We got our capacitors replaced. That's the important part. Not really, these are much more important than the capacitors. So it almost certainly work fine indefinitely with at least those two capacitors that we had to remove. It's not even on the board. So there for redundancies. For example, this little one where the pad's gone right under where I'm wicking right now, we really don't need that here, and it would be a big headache to run a wire to it and do all this crap, so we're not going to do that. rework section. One other thing I wanted to show on here is this keyboard is like all reverse dented. It's pretty bizarre. I guess we'll see if it works. Kind of assume it won't. This doesn't feel normal to me at all. It's kind of poofy everywhere. Pretty weird. I don't think I've seen that before. They maybe tried to heat it a bunch or something after they spilled liquid on it. I'm going to dust out the inside of this chassis a little bit, and then we'll reassemble it and test it out, see if the audio works, that sort of thing. But it is turning on now, so I assume it'll be fine. We'll know momentarily. All right, MacBook lives, but we actually don't have the passcode, so I can't test it fully right now. It did make the startup Apple sound and seems fine. To kind of reiterate on this, what was our problem? I mean, there's liquid damage in this area around the speaker amp, primarily right here. There was a little bit of corrosion under this chip. This was probably fine. Almost certainly this was our only exact problem, was this speaker amp, and I reckon with a failure on any of these speaker amps you'd see similar behavior, at least if it was what we had here. So we'd see 0.9 volts on PP bus underscore AON. And then same thing here, like these PP bus speaker amp lines are basically the same line, they're just called something else. Our main 12 13 volt was at about 100 ohms to ground, I guess like 90 to 100, and something under here was pulling that down. Basically we can actually very lightly see this thermal signaling on the thermal imager, which is how we found that. In a more kind of smash your thing with the rock kind of approach, you could have just sort of replaced all the stuff in this area, which obviously is kind of inefficient. But even in that case too, it's like this stuff just looked clearly bad, so we removed it. We could see a burn pad under here. We don't really care about this capacitor. It's 0.1 UF versus the cumulative capacitance of this line is like just for example, right, this is what, 100 times more capacitance than this. We don't care about this. This is like less than 1% of the total capacitance on the line. Does not matter. Pad was burned on it. It'd be a little bit of a process to do, so we're going to skip over that one. And then the other thing we saw there was this guy here. Now there's just like a couple capacitors on this line. I kind of assume this might be important. It's like a supply line to the PMU basically, but I think there's like a few other capacitors on this line. Probably fine without it, but whatever, the pad was kind of natively salvageable. We got a new one on there. These two capacitors in this area and this chip. This device is going to need a new battery too. The keyboard seems to work fine, which is kind of surprising. I'm not sure like the backlight's like bulging on it. Maybe the keyboard backlight might not work. We'll see, but that's honestly a pretty minor function, and the keyboards are really expensive, so we might just skip that. In any case, hopefully this helps someone who has an M3 MacBook, or realistically an M1 or M2 would probably behave in a similar way with the same failure. 0.9 volts on PP bus AON and about 100 ohms to ground. You inject voltage into PP bus, you don't see anything actually get hot. It's not pulling current, but we could see really light thermal signaling on the on one of the audio drivers in this area. So we'll see you in the next repair video, whatever that may be.